Start going? Okay. So thank you very much, everyone, for attending today's session. We're going to talk around how we're going to abuse the existing software supply chain, specifically with this high-velocity introduction of AI. So I think the clicker should work, and if not, it's fine for me just to click next on the... So yeah, I work for a company called Cloudsmith. Cloudsmith are a registry solution, put it simply. So you'd see other organizations in this image registry area. We obviously do other things than just software images, Docker containers, those kind of things. We also deal with everything that comes from these open source software package managers. So things like PyPi, NPM, Maven, those kind of hubs. So essentially the world is reliant on open source software written by other people. We are just that registry so that you can securely consume those software packages and components. I won't go into what Cloudsmith is, but this just gives you a high-level introduction into what my organization is working on today from a security perspective. So we're going to talk around AI. We did a report. It's actually a year ago at this point. We've done another one since for 2026, but I think some of the reports still hold up today, findings. So the first part is around security. Well, there's a security blind spot around AI. We'll talk around this idea of typosquatting. It's an age-old security problem. But now slopsquatting is the new variant of typosquatting and how that really makes sense. We'll look at existing research specifically in that area of slopsquatting and what that means for the industry at large. We'll talk about open infrastructure. I think this is a big topic as of, well, yesterday. OpenSF opened up an existing paper around the fact that we need to now think about open infrastructure. Everyone's using it. It's not free. It costs a lot of money to actually run this infrastructure. We'll talk about the recent software supply chain attacks. And again, this all ties back to the fact that this is open infrastructure. It's open source and anyone can contribute. Whether good, yes, but then there's also bad actors out there. And I'm going to give a demo and I'm going to show really how we can do kind of proactive steps to stay secure in this world. So going back a year ago, I remember someone wrote an article on Financial Times, and it was a piece about vibe coding and why it's the DIY of the world, where anyone can do it yourself, like building your own kitchen furniture kind of thing, you know? And I wrote a small piece back to it. It really was just one of those little letters. And I basically said, DIY is great. Anyone can build your own stuff. But if you're anyone like myself who's not very good at carpentry, you're going to end up breaking things all the time. And that's kind of where we're going at the moment when it comes to security. Everyone's writing code, even non-technical stakeholders. Problem is, a lot of this is like scaffolding that's not kind of sticking together. And I'll show some of those examples in a while. I don't know why, but this very small letter I wrote started appearing in other publications like Forbes, and I really don't know why. But again, it was just that piece around scaffolding, so it seemed to appeal to other software developers who seem to resonate with that topic in mind. If you're not familiar with the term vibe coding, I think everyone already is. People are doing real coding. That's where you think about what you do and you write it and you kind of have a plan of action. Vibe coding is going by vibes, so you're not really thinking about what are the design. You often just go by vibes and you just generate code and it either works or it doesn't, and you reiterate on that code. That's the simple definition of it. According to Andrej Karpathy, it's just that concept of, again, using LLMs to generate code. So AI is now a new security blind spot. We ran this report. We had a bunch of different findings came out of it, but some of them were quite interesting and probably make obvious sense now in 2026. But it's this idea that pretty much everything showing up in code base is now AI generated. I know, obviously, the heavy majority of our code isn't actually code we wrote ourselves when we think about open source dependencies, libraries, all of that stuff that builds up our overall code base. But again, of the stuff that is being generated and put into the code base by us, it's pretty much all AI generated at this point. And that was the sentiment that was coming back in these survey results. The other side was, while people were saying, okay, we're generating code and that's all great, we're solving the velocity issue, most organizations were genuinely coming back from these tools like Cursor and Claude and saying, yeah, actually, we're having some security concerns. When asked simple questions like, do you believe AI will exacerbate open source malware threats? The heavy majority said yes, of course. You know, I don't think there was any concern that we were going to introduce more problems, because fundamentally, if we don't know what we're doing, it's the same old security issue before. We just don't know what we don't know. That's basically it. We asked other questions like how much of your code base was AI generated. Again, how accurate these results are is really just down to survey results. We surveyed software developers specifically using AI coding tools today. So we hope that the answers are somewhat substantially accurate. But again, most were coming back saying, yes, you know, we have AI throughout the code base at this point. When we're talking about where were they using AI today, I think that's going to change a lot from last year's results. But a year ago, everyone was using it just for code generation. It wasn't in the QA process. It wasn't so much in design documentation and the deployment phase. They were really just generating loads of code. That was the velocity argument. That was the value proposition that came from AI. So again, that will probably change in later results and surveys. But when asked the question like, how do you feel around malicious code and being able to see what is or is not safe within your code stack, I'm pretty sure people would have given the same answer before AI, but most are coming back, or a large percent are coming back and saying, yeah, we don't really feel confident that we actually are able to identify malware within our open source stack. So the idea that we didn't write this code, we're less aware of what we're actually introducing into the code base. So that's where typosquatting and slopsquatting comes into it. I use this funny example where, you take two drinks that look the same, they're stout and they're same color, same top, everything's identical. And people think of typosquatting like this, where it's two different brands and you miscommunicate with them. It's more like simple typos. You take two brands, they're almost identical, you swap out an A for an E, something very, very simple. Again, the common scenario we see here is that people find a typosquatted package, they panic, they remove it, then later they go through the whole cycle again. It's a repetitive cycle. This has existed for years. This is not an AI-specific problem. This is just a simple cybersecurity problem. If you can file something, a website, domain, a software package name, and you can make it look legitimate to someone, you're hoping that they type really fast, make a mistake by spelling, and accidentally go to the wrong website or pull the wrong package name. Very simple attack surface. You can see typosquatting here. A simple example is you go to wellsfargo.com and you drop an O in com and you go to a wrong, suffix or domain extension, whatever it is, and next second you're downloading malware. That is the basic example of typosquatting. What slopsquatting is this idea that we now use LLMs and they are blindly providing stuff to us. The attack surface is something very rudimentary like this, which is I go to LLM and I say, I need Hugging Face CLI because that is how I'm going to interact with Hugging Face. For those who don't know Hugging Face is just a big registry for pulling LLM models and data sets and anything to do with building your own open source LLM model stuff. The idea here is, I don't know why, but ChatGPT hallucinated and it started giving fabricated package names. It's this thing that happens. They're trying to address it in the frontier models, but it's still an outstanding problem in the industry today, where you ask for something, you'll either get the literal response back, or due to complex requirements inside your request, you're ending up getting, again, the package didn't exist. But what happened was a security researcher realized, hey, I ran pip install on that package name, and it literally just throws up an error saying that package doesn't exist. So this guy, Barlin Yardo, who I can't remember what organization he worked at, but he basically in 2023 published a paper where he said, hey, I just filed that package name when I realized it didn't exist. I was just curious how many other people were doing the same thing. He realized 30,000 people were obviously doing exactly the same thing, because 30,000 downloads were made over a 3-month period, pulling that fabricated package name, proving the point that a simple example of hallucination in the LLM is people have got blind trust now with LLMs. You're saying we're moving fast, we got velocity, we're pulling things. Problem is, it's not surfing the web. It's not going to the package registry and checking, is this a valid package? Is this a valid author? It's not checking for provenance. It's simply just saying, yeah, sounds good enough to you, and here you go. If it's not good, again, by vibes, we'll just keep doing it until we get the right CLI tool. There's no design documentation or implementation around this. So again, simple attack surface, it's just an extended logic on typosquatting. But what people are realizing is, if we find package fabricated names from LLMs, what if I just register those said names into the hubs, whatever it be, PyPi, NPM, Hugging Face CLI, there's dozens of registries. So research in this area. This was a piece done by Trend Micro. Again, data is constantly changing. What was frontier at the time was like GPT 4.0. We've moved a long way on since then. But what they realized is, across the board, what was happening was the more context, the more complicated really the requirements were within that LLM request. Within the payload is what is actually leading to these instances where they see in the heat graph more and more fabricated names. It just simply wasn't a please find me exact package name for a thing. Instead, it was like complex deployment requirements, and in the process, it fabricated a package name here or there. Simple little mistakes, but again, you got kind of pawned in that scenario. So in this one, they went over 100 tasks. Again, foundational models were predominantly finding zero hallucinations. That was pretty common. That's a good thing. That's the expected outcome of these LLMs. But when they started bundling these novel libraries, you started doing morphemes. So you're doing like graph, orm, wave, socket. You're doing lots of, again, different context into it. That's when it was sounding plausible. And it was saying, because again, think about it, an LLM is just predicting next word. That's essentially all it is, a next word generator. So the more context you're adding in the next more possible things it can get hiccups on, and eventually it's generating those outcomes. And again, the trend right micro paper is probably the best one for showing these outcomes. There was a load of other things, time-related signals. Again, if you're asking for specific time periods, specific versions, when you start asking for more specific things, that's when it starts going wrong, as opposed to generic requests. And that is just a known problem in LLMs today. They were seeing like Llama was a model that did really well. Again, we've moved a long way on, but Llama in general do quite well. These open source models at addressing the issue of hallucinations, and again, kind of tailored for that purpose. ChatGPT isn't probably focused specifically on just being a coding agent. It's a general purpose. Again, frontier model does pretty well at what it needs to do, but again, it makes mistakes. The next problem, it's related. So we talked about slopsquatting, typosquatting, and the fact that packages are going into registries and people are filing them, and they are bad code, essentially, that we end up downloading. But we download it from these registries. So PyPi, the Python package index, you have Node package manager from JavaScript. So all the languages have their own registries. This is a really scary piece. This came out yesterday. So again, this is part 2 of an ongoing series from the OpenSSF. So this is the Open Source Security Foundation, for those who don't know. They are the ones who set up kind of governance controls and kind of really work in building open source projects and making sure that all of this is stable and will work for years to come. So what they've said is, look, 10 trillion, I'm not making these numbers up, but you can look at the report yourself, 10 trillion open source download packages are going to be made in 2026 from these indexes. It's a terrifying thing. We're seeing 1 billion per hour. The idea now is everyone and their mum is now generating code. It's a reality. We're all told, let's use AI agents, let's vibe code, let's just be software developers. So the idea is more velocity, more code generation, but also a lot of code. If I say generate me Python script.py file, it's also going to just generate a bunch of imports, and it needs to pull these packages, these requirements, and they're all coming from these indexes. So again, it's open infrastructure. It's free for us to use it, but it's not free. It's literally costs a huge amount of money to run this infrastructure. So you think about the likes of Rust Foundation, Maven Central, PyPi, NPM. There's a huge amount of these registries for all these languages. The numbers are constantly going up. I think this is just a scary reality of where we're going, which is more and more demand for AI, more and more demand for these registries. This is the software world we're living in today. The problem with it, at the end of the day, it's open source. These are open registries. Anyone can commit, anyone can get involved. As we get more velocity from software development, so do adversaries, hackers. They can contribute to these registries as well. So again, I say the AI boom presents big challenges. It's a big, scary thing, which is we're seeing, yes, more and more legitimate code. People can publish packages, dependencies that they never could in the past, which is great, or projects they struggled at getting contributors to their project are now solving some of those problems that they had that were outstanding. And this is all really exciting. Again, I point to that OpenSSF piece at the bottom about the hidden cost of running package registries. But the real scary part is, as we're seeing more and more packages going to the registry and there's more and more authors, it's really hard to question the provenance thing of what do you trust? What can you use? Did we even really have trust boundaries to begin with around the software packages we brought into those registries? So again, even though it's all great and good, bad people are, I don't know if I did anything to disconnect that. Oh, it's back. That's great. So yeah, bad people are also publishing too. I don't know why it's gone. Still on my screen. Will I unplug and plug back in? Okay. We'll wait 2 minutes. Does all this make sense so far to people? Yeah, okay, cool. And everyone's still enjoying it? Okay, great. So now we're going to touch on the really interesting ones. Recent NPM supply chain incidents. I don't want to leave it at just NPM. There's so much more than NPM. But Node Package Manager, for those who don't know, this is where NPM packages, your JavaScript packages go into them. Shai Hulud was the big incident, for those who don't know. Well, first of all, it's the whole Dune reference. So the big worm, Shai Hulud, that's the campaign that they're running anyway. This malware, this data stealing malware, it's really scary. But you'll see like every security vendor was publishing piece about Shai Hulud. This went on, I don't know, 2-3 months back. But recently, chainguard.dev, they published their threat protection AI page. You can definitely check that out. It lists all of these packages that were compromised. And you can see that in these reports, they're basically on a near daily basis that another package is being published to a registry, whether it be NPM or PyPi. And they're all terrifying in the sense that these software dependencies, whether we know it or not, the likes of Axios, the request package, these packages get millions and millions of downloads every day. So we're all using it, whether you know it or not. It's a dependency inside our stack. So if someone compromises it, they publish a bad package to the registry, and we say, for instance, blindly pull the latest from it because we're just vibe coding, you're in, without knowing, downloading malware. And that is the reality where we're at. So the Shai Hulud incidents, we're looking at Light LLM and PyPi. There was the Trivy incident, the vulnerability scanner. There was Team PCP, this organization that were actively going out to publish this malware into these registries. We've been dealing with a lot in the last 2 months, really. It's spiked. And it damages the trust in these registries because people are saying, goodness, I just got affected by that incident, and you're telling me 3 weeks later I've been impacted again. It's really upsetting. You'd think about Log4Shell. Log4Shell was a massive security vulnerability. Back then, not everyone was generating SBOM. Not everyone had a full understanding of what software components existed within their software development stack. So they didn't know, did I have that vulnerability? And if so, what were the steps to mitigate it? Apparently 10% of year's enterprise security that year was spent in just trying to mitigate the CV itself for Log4Shell, which was the Log4j Apache component. Again, we're just going to see more and more of these appearing over the years. That's just a sad reality. But there is a solution. So I mentioned OpenSSF. They're the organization who steward these open source projects and these registries and making sure open infrastructure is open and stable for the future. Google created this project, this fuzzer called Open Source Vulnerabilities, and then they donated it to the OpenSSF. So it is open source, open infrastructure, brilliant, So here's a blog from 2022. Again, it's been a few years now. That Google published, and they were just saying, hey, we released this OSV scanner. OSV scanner is awesome for those. Is anyone using OSV here? Or is this... No? Okay, you should. For a few reasons. It's free, so you have no objection as to use it. Open infrastructure. The other piece is that realistically, it's very, very powerful. There are lots of registries. There are lots of threat-informed reports. Google's fuzzer scans the registries, so it finds out, is there something that is known to be malware inside those packages? Whatever defines malware, a crypto miner, or typosquatting, whatever it is on a package name that's legitimate. They do all that for you, and then they create these reports into this giant report database. So the idea is, if you want to scan, let's say in this screenshot, you scan your lock file or your requirements.txt file, what it'll do is it'll say, here are all the dependencies. These are the ones that are affected on these versions. And here's our advisory that actually tells you like why that's a problematic. It initially was created for vulnerabilities as per the name, but then they created another extension.
Collecting web data shouldn't be this hard. Scaling equals complex infrastructure. Advanced bot systems blocks you. Heavy data loads break pipelines. Oxalabs can fix this. Curious? Meet us at booth A0021. Fast adapting infrastructure for web data. See it in action. Real-time data for AI models. Track pricing and market trends. Reliable business intelligence. 177 million IPs. 195 plus countries. Oxalabs, fast adapting infrastructure for web data.
Either by hash or or they can also do it based on like package name and version, very simple stuff. So it has a scheduler running all the time. Again, we don't pay for this. Google's doing all this on their own. So they scan it for the package needs, then they do to get it. And that's super awesome across all those registers. Again, they're doing it all for us. It's free. That's OSV. There's also other projects that come along like OSM, which are dedicated purely just to looking at malicious packages.
Collecting web data shouldn't be this hard. Scaling equals complex infrastructure. Advanced bot systems blocks you. Heavy data loads break pipelines. Oxalabs can fix this. Curious? Meet us at booth as0021. Fast adapting infrastructure for web data. See it in action. Real-time data for AI models. Track pricing and market trends. Reliable business intelligence. 177 million IPs. 195 plus countries. Oxalabs. Fast adapting infrastructure for web data.
Amongst others. So in this case, it makes it easier to read. So I'm basically saying, check out the script. I'm checking it's going to be in the registry PyPi. So in this case, request is a legitimate That's a simple change, right? That's typosquatting in its finest. I run the same request, again, it runs those two APIs, and suddenly you get this huge output. The idea here is it telling us, okay,
Collecting web data shouldn't be this hard. Scaling equals complex infrastructure. Advanced bot systems blocks you. Heavy data loads break pipelines. Oxalabs can fix this. Curious? Meet us at booth as0021. Fast adapting infrastructure for web data. See it in action. Real-time data for AI models. Track pricing and market trends. Reliable business intelligence. 177 million IPs. 195 plus countries. Oxalabs. Fast adapting infrastructure for web data.
We had this script here. Actually, I think I probably already did it. Wrote this custom script, and the reason for it is I have a running container, so this container is a lot of it's other people's code. So I want to scan pip, and I want to say what are the packages that are
Collecting web data shouldn't be this hard.
Scaling version, and the idea here is you can run it whatever way you want. It's an open API, so in this case, I can check, hey, I could have dozens and dozens of dependencies that exist in a container, but if one of those is typosquatted, I want a simple way to query and say, hey, look, in clear as text, that one is known to be malware. You have malware in a running container. Kubernetes doesn't really have malware scanners. It's not really a thing that's thought of in Kubernetes, mainly because Kubernetes is supposed to be like dynamic and pods die and they relive and they go up and down all the time. But if in your build process you're introducing malware that was typosquatted as per, vibe coding, you're just going to keep reintroducing this malware over and over again. So again, it's a really useful way of scanning and identifying the malware. The other thing I wanted to show off, and I think it's really important to show it, is, this was also how to create the fake malware. It's literally just create a fake name and ID. There's actually nothing in the file. But the thing I really wanted to show off was, so you can just run a post request against the API, quite literally, again, JSON structured output, that's all pretty normal. But the other thing that's, I think, very important here is OSV scanner. So I think I had an example from earlier that I had running up here. Again, dozens of different scripts inside here, OSV scanner. So I have a requirements.txt file, very simple. It could be a lock file. Any of those formats are recognized with an OSV scanner. I mentioned Google mentioned that they have this OSV scanner. You can run as CLI or you can run as GitHub. You can run as like an action. You know, all of these things can be defined. So in this case, I have a text file. My text file is literally cat requirements.txt. So you can see it's just requests, light LLM, pandas. That's it. But what it'll do is by scanning those 3 packages on those specific versions, it will give you the full audit trace to say, hey, here are the packages. You can see light LLM requests on the versions. You can see what source it was scanned from. Imagine you can scan literally your whole file system and get an advisory on everything, or external hosted location. So again, you can use it whatever way you want. But in this case, when we talk about that mal ID, it's saying that light LLM on that specific version has both a PySec advisory, but also the malicious advisory. So you can go to osv.dev, go to mal.whatever, and that's it. I think I'm done on time, so thank you very much for attending.